In this episode, we move from the idea that artificial intelligence, AI, creates risk into the more practical question of how organizations are supposed to guide its use responsibly. New learners often hear words like fairness, safety, privacy, transparency, and accountability so often that the terms can start to blur together and sound like general values rather than working principles. That can make responsible AI seem vague, even though these principles are meant to shape real choices about design, data use, deployment, oversight, and ongoing monitoring. A helpful way to approach them is to treat each one as a lens that reveals a different kind of concern. When those lenses are used together, they help an organization ask better questions before a system is trusted, scale a system more carefully, and respond more effectively when something starts to go wrong. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.Author.me in the Bare Metal Study Guide series. Responsible AI principles matter because organizations rarely fail only because they lack technical skill. Many failures happen because a team focused on whether a system could be built and moved too quickly past whether it should be built in the same way, for the same purpose, with the same data, and under the same level of oversight. Principles help slow that drift by giving people a shared way to judge the system beyond simple usefulness or speed. They also create a bridge between technical teams, legal teams, risk teams, privacy teams, and business leaders, because each group can use the same principles to discuss concerns from different angles. That shared language is one reason principle-based governance matters so much. Without it, one team may talk about efficiency, another about compliance, another about reputation, and another about customer trust, while nobody notices that they are all describing different parts of the same governance problem. Fairness is often the first principle people think about, but it is also one of the easiest to oversimplify. At a basic level, fairness means an AI system should not produce unjustified or harmful differences in how people are treated, evaluated, ranked, or affected. That sounds straightforward until you realize that fairness is not always the same as treating every person in exactly the same way. Sometimes equal treatment can still produce unequal effects if the system ignores real differences in context, access, language, disability, or historic disadvantage. A fairness discussion, therefore, begins with a serious question about who may be helped, burdened, excluded, misread, or disadvantaged by the system. For a beginner, the most important habit is to stop thinking of fairness as a vague moral decoration and start seeing it as a practical examination of how outcomes, opportunities, and burdens are distributed across real people. Applying fairness means looking beyond overall performance scores and asking whether the system behaves unevenly across groups or situations that matter. A hiring tool might look accurate in the aggregate while performing worse for applicants with non-traditional work histories. A language system might function smoothly for some writing styles, but misunderstand people who use regional phrasing, translation software, or assistive technologies. A customer support model might appear efficient while quietly giving weaker responses to people whose questions are framed differently from the examples it saw during development. Fairness also requires attention to the purpose of the system, because a tool built for one setting may become unfair when reused in another without careful review. In practice, fairness is not something a team declares once and then assumes forever. It is something that has to be examined during design, testing, deployment, and ongoing use, because unfairness can emerge from data, objectives, assumptions, or the way humans act around the system. Safety is another principle that beginners often associate only with physical harm, but in AI governance the idea is broader than that. Safety means a system should be designed, tested, deployed, and monitored in ways that reduce the chance of harmful failure. In some environments, that may involve obvious physical concerns, such as whether a system influences medical advice, industrial processes, transportation, or access control. In other environments, safety may involve informational harm, emotional harm, operational disruption, or the escalation of risky decisions because people relied too heavily on an output that sounded confident. A system can be unsafe because it produces false information, because it behaves unpredictably in new conditions, because it fails silently, or because people are encouraged to trust it beyond what its limitations justify. Safety, therefore, includes both the quality of the system and the quality of the environment into which it is introduced. Applying safety requires teams to think carefully about use context rather than relying only on lab performance or vendor promises. A model may work well during testing, but behave differently when real users interact with it at scale, especially if the real-world inputs are messier than the examples used during development. Safety-minded governance asks what the system is allowed to do, what it should never do without human review, what signals indicate that it is drifting or failing, and what controls should be in place when mistakes would carry serious consequences. It also asks whether users understand the system's limits or whether the interface encourages misplaced trust. A fluent answer, a polished summary, or a neat prediction can create a false sense of reliability, and that is a safety issue because people often act on what feels credible before they verify what is true. Safe use depends not only on the model but also on boundaries, escalation paths, fallback processes, and honest communication about uncertainty. Privacy becomes especially important in AI because so much of the technology depends on large amounts of information, and organizations can become careless when data seems easy to collect, combine, store, or reuse. Privacy is not only about secrecy. It is about respecting the conditions under which information about people is gathered, used, shared, inferred, and retained. An AI system may create privacy concerns even when it is not trying to identify anyone directly, because patterns in data can still reveal sensitive traits, personal habits, or unexpected connections. Training data, prompt data, user interactions, outputs, logs, and monitoring records can all raise privacy issues if they include more personal information than necessary or are used beyond the purpose people understood. For a beginner, the practical lesson is that privacy asks whether people are being exposed, profiled, tracked, or analyzed in ways that exceed what is justified for the system's legitimate purpose. Applying privacy means making careful choices before data ever reaches the model and continuing that care after deployment. Teams should ask whether they truly need all the information they plan to collect, whether sensitive information can be reduced or separated, whether the purpose is specific enough to justify the data use, and whether people would reasonably expect their information to be used in that way. Privacy also matters in system outputs. A generative system may reproduce sensitive details from its training environment, expose confidential information through careless prompting, or create summaries that reveal more than the user intended to share. Strong privacy practice, therefore, includes limits on collection, thoughtful design of data flows, access controls, retention discipline, and review of whether the system creates new personal inferences that deserve extra caution. Privacy is not something that sits outside AI governance. It runs through training, testing, deployment, and everyday use. Transparency is the principle that helps people see enough of the system to use it responsibly, oversee it appropriately, and challenge it meaningfully when needed. Transparency does not mean revealing every technical detail to every audience, because that would often overwhelm users rather than help them. Instead, it means providing the right kind of clarity to the right people at the right time. A customer may need to know that they are interacting with an AI system rather than a human. An employee may need to understand when a tool is giving suggestions versus making decisions. A governance committee may need documentation about training data sources, limitations, testing results, known weaknesses, and approval conditions. Transparency matters because trust built on confusion is fragile. When people do not know what the system is doing, what role it plays, or where its limitations lie, they are more likely to overtrust it, misuse it, or fail to spot harm when it occurs. Applying transparency requires organizations to think about explanation as a practical responsibility rather than a public relations exercise. The goal is not to make every system sound impressive or harmless. The goal is to help stakeholders understand what the system is for, how much reliance is appropriate, what data or factors matter to its operation, and what limits or review channels exist. In some cases, transparency may involve notice to users, internal documentation, model cards, approval records, or clear labeling of automated content. In other cases, it may mean explaining that the system supports human judgment rather than replacing it. Transparency also has limits, and that is important to understand. An organization may need to balance openness with security, intellectual property concerns, or the risk that too much disclosure would enable abuse. Even so, limited transparency is not the same as no transparency. Responsible governance still requires enough visibility that decisions are understandable, and responsibility does not disappear behind complexity. Accountability is the principle that holds the whole structure together because it answers the question of who is responsible for what. Without accountability, fairness becomes a discussion with no owner, safety becomes a hope rather than a practice, privacy becomes an afterthought, and transparency becomes selective or incomplete. Accountability means that specific people, teams, or governance bodies have defined duties across the system lifecycle. Someone is responsible for approving the use case, someone for reviewing data practices, someone for validating performance, someone for monitoring after deployment, and someone for responding when the system behaves in an unacceptable way. For beginners, accountability should not be understood as a hunt for one person to blame after something goes wrong. It is better understood as a clear assignment of authority, responsibility, and escalation before the organization starts relying on the system in the first place. Applying accountability means refusing to let important decisions dissolve into vague collective ownership. If a business unit wants a new AI tool, it cannot assume the technical team will handle every governance issue. If a vendor offers a promising system, the organization cannot assume the vendor's claims replace its own duty to review risk, privacy, fairness, and operational fit. If a model is deployed, the people who approved it cannot act as though their role ended the moment the system went live. Accountability continues because systems continue to affect real people and real decisions after launch. This principle also requires documentation and traceability. When a team can show who approved the system, what conditions were attached, what testing occurred, what limitations were known, and how ongoing review is supposed to work, it becomes much easier to manage risk responsibly. Accountability makes governance real because it ties principle to action and action to identifiable owners. These principles are often discussed one at a time, but in practice they constantly interact and sometimes create tension with one another. A team may want more transparency, yet have to consider privacy and security when deciding how much to disclose. A system may improve safety by gathering more context, while that same data expansion raises privacy concerns. A model may become more explainable if simplified, but the simpler version may perform worse in ways that affect fairness or usefulness. Responsible AI does not mean pretending these tensions do not exist. It means recognizing them early and making deliberate choices rather than accidental ones. That is one reason governance needs cross-functional review. When one team focuses only on accuracy, another only on privacy, and another only on business value, the organization can miss the trade-offs that appear only when the principles are considered together. A practical way to apply these principles is to use them as recurring questions at every stage of the life cycle rather than as a final review checklist. During planning, a team can ask whether the use case itself is fair, necessary, and aligned with the organization's values and obligations. During design and data preparation, the team can ask whether the system creates avoidable privacy exposure, whether some groups may be disadvantaged, and whether the intended safety boundaries are realistic. Before deployment, reviewers can ask whether users will understand the system's role, whether human oversight is meaningful, and whether ownership is clear if problems appear. After deployment, the same principles help teams monitor complaints, drift, misuse, uneven outcomes, and reliance that grows beyond what was originally approved. When the principles are treated as ongoing questions instead of slogans, they start shaping real behavior across the organization. A beginner should also understand that applying responsible AI principles is not about making systems perfect, because perfection is not available in technology or in human decision-making. The goal is more disciplined judgment, fewer preventable harms, and better control over how powerful tools are introduced and used. A responsible organization knows that systems will have limits, that context matters, and that oversight must continue after launch. It also understands that values become meaningful only when they influence approval decisions, data choices, user communication, monitoring practices, and escalation paths. Fairness, safety, Privacy, transparency, and accountability are not separate decorations attached to the outside of an AI program. They are the working standards that help determine whether the system deserves trust, whether that trust is bounded correctly, and whether the organization is prepared to respond when trust is tested. As you finish this lesson, hold on to one simple but important idea. Responsible AI principles are valuable because each one helps reveal a different kind of weakness that might otherwise stay hidden until the system has already caused damage. Fairness asks who may be treated unjustly. Safety asks how the system could fail harmfully. Privacy asks whether information is handled with proper restraint. Transparency asks whether people can see enough to use and govern the system wisely. And accountability asks who is answerable throughout the process. When these principles are applied together, they do not just make an organization look responsible on paper. They help it make better choices about whether to build, buy, deploy, limit, monitor, or stop an AI system. That is what responsible governance looks like in practice, and it is why these 5 principles sit so close to the center of modern AI oversight.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.